Now, guys, this is exercise 5.7, okay? And this is question 3 on 5.7. So, a boiler is in the shape of a cylinder. A boiler is in the shape of a cylinder with hemispherical ends, as shown in the diagram. The total length of the boiler is 30 meters, and the diameter is 12. If the diameter is 12, that makes sure it's 6. Come again. This makes it 6, and this one here makes it 6 as well. 30 take away 6, take away another 6 is 18. Okay, so it's 18 is the actual length there. Okay, so we're going to do the length. We're going to find the area of the cylinder first. The volume of a cylinder is pi r squared h. And as you can see, it's pi times r squared, which is going to be 6 squared. The height of the cylinder is going to be 18. So what's that in the calculator, lads, in terms of pi?
648.
648 pi? Yeah. Okay, so 648 pi when you put that into the calculator. Now, we have two ends. Both ends are hemispheres, and therefore the full thing is a sphere. So we're looking for the volume of a sphere. The volume of a sphere is 4/3 pi r cubed, which is going to be 4/3 multiplied by pi multiplied by cubed. What do we get for that? 4/3 multiplied by pi multiplied by 6 cubed. And we get 288 pi. Now also what we need to do next is add these together. 648 plus 288. And we get 936 pi. So total volume. Who got this one now? That's 936. Only Harry, is it? 936 pi centimeters. Centimeters cubed. Okay, now that's done. What happens here is that's just the solution. In the black is the solution for the volume, okay? And what we're going to be concentrating now is on the surface area. So this one, the surface area solution will be in red, okay? So what we're doing next is we're figuring out what is the surface area. Now it's basically, as you said before, it's a sphere because both hemispheres go to a sphere either side, and then the cylinder is. It's basically we can't take the two circles at the end because the two circles at the end aren't included because they're covered by the dome, so to speak, or the hemisphere. Okay, so we're looking for the curved surface area of a sphere plus the curved surface area of a cylinder. Okay, so let's figure out what the curved surface area of the sphere is. Okay, so we go to the sphere, look up area. Area is going to be 4 pi r squared. The surface area of a sphere, and remember we don't want the two circles, we only want the curved surface area is 2 pi r h. Okay. So let's put in the figures for this one here. It's going to be 4 times pi times 6 squared. A for the cylinder is going to be 2 multiplied by pi multiplied by 6. What's the height of the cylinder again? 18. So put them into your calculator, and what do we get? 144 pi for this one. And the other one? 216 pi. Yeah. And then when we add them together, 360 pi. So lads, that's the answer to that. Remember, it's centimeters squared and not centimeters cubed, okay? This here's question 7, okay? Question 7. Just nothing to do with question 7 here. Any speaking, guys? Come on, keep it quiet. No speaking. Okay. Now, A wax crayon is in the shape of a cylinder of diameter 10 millimeters and surmounted on a cone of slant 13 millimeters. Okay, find the vertical height of the cone. Now, if we write down the cone part of this question, okay, what happens is we're just going to we have to find out, we know what the slant height is, but we have to find out is what is the height vertically, okay? So we need to find out what is the height of the dotted line here, okay? So to find out the height of the dotted black line, we need to do Pythagoras' theorem. Now Pythagoras' theorem says that the longest side of the hypotenuse is 13. The radius of this has to be 5 because it's half of 10. We now have to figure out what x is. So it's going to be 30 squared equals x squared plus 5 squared. That's going to be 169. This 5 squared is 25. Bring the 25 out the other side. Minus 25 equals x squared. 144 equals x squared. And this means that x therefore has to be equal to 12. Okay? So that makes the height of that 12. So now that we figured out what, that's the answer to part 1. Okay. So we're going to, next part is show that the volume of the cone is 100 pi millimeters squared. Okay. Okay. Show that's 100 pi millimeters squared. So when you do that, okay guys, okay, so that's part 1 there, okay? Now we're on part 2. Now part 2 is show that the volume of the cone is 100 pi millimeters squared. So you look up the volume of cone in your formula. And when you get the volume of cone, it's going to be a third pi r squared h. Okay? So a third pi r squared h. Okay. Equals a third pi r squared h. Okay? A third pi multiplied by r. The radius of the cone is 5 squared, and the vertical height we just got is 12. So can somebody put that into the calculator quickly and tell me what it is? It's going to be 100 pi millimeters squared. Okay? So that's the answer from there, okay? So that's part 1 to the left, part 2 in the middle, and now we're going to do part 3. Okay? Part 3. Given that the volume of the cylinder is 15 times the volume of the cone, find the volume of the crayon in centimeters cubed, correct to 1 decimal place. Okay? So what this means is for part 3, what we're going to do is we're going to say that we have to multiply the volume of the cone by 15, okay? So 15 times the volume of the cone is going to be 1,500 pi. Okay, 1,500 pi. Now, it says find the volume of the, full crayon. So that means we actually have to add on the cone itself, okay, which is 100 pi. Okay, 100 pi, and that's going to get me 1,600 pi. Now there's two problems here, okay. The first problem is it's in millimeters squared, and the second problem is it's in pi. So what I'm going to have to do is change 1,600 pi into millimeters, okay? And just press the change button. I'm going to round up to 2 decimal places, okay? Now, so this answer here, so it's 5026. I'm going to keep the rest of I'm going to keep a couple of extra decimals, and I'm going to tell you why I'm keeping the extra decimals. I have to convert millimeters squared into centimeters squared, so if I put down 2 decimals, I actually might lose those 2 decimals. So I'm going to write down every decimal that's there, okay, and then I'll round it off at the end. What's it? 54826, isn't it? 246. Alright guys, now what's happening next is we have to figure out what is the conversion rate, okay? So remember how I told you how to remember this, okay? What you do is you draw a cube, and the cube you draw is 1 centimetre across each way. 1 centimetre by 1 centimetre by 1 centimetre. The volume is 1 centimetre cubed. If I was to draw the same cube again, but this time I measured it in millimeters, it's going to be 10 by 10 by 10. Okay? 1,000 millimeters. 1 centimetre cubed equals 1,000 millimeters cubed. So if I divide this number by 1,000, I get the answer in centimeters cubed. Okay, so I'm just going to get my last answer and divide by 1,000, and what I'll get is 5.0265. Asked it to 2 decimal places, didn't it? So 5.03. Okay, so 5.03. 03 centimeters. Sorry, that was centimeters cubed. Okay. Who got that one now?
Yeah, it's 5.02.
02. Okay. Some people say the answer would be 5.02, but you can see here that they must have rounded it off incorrectly, so the answer is 5.03. Okay. Alright. Next one is question 4, okay? And question 4 is I think it's probably going to be find the height, is it? How many complete crayons like this one can be made from 1 kilogram of wax, given that each centimetre cubed of wax weighs 0.75 grams, okay? So to do this question, and I'll do it in the middle here. To do this question, we're going to have to figure out 1 kilogram of wax. We need to change 1 kilogram into grams, which is 1,000 grams. Okay? Once we've done that, we have 1,000 grams to use. We need to figure out what the weight of 1 crayon is. Okay? Now 1 crayon is going to be 5.03, which is how many centimetre cubed we have, and we're going to multiply that by 0.75 grams. So we're going to find out how many grams does 1 crayon weigh. Alright? So 5.03 multiplied by 0.75. Each crayon weighs 3.7725 grams. Okay? What we got to do next is we got to divide 1,000, our total weight of wax we have, divided by the total weight of 1 crayon, which is the underlined in blue. So what we're just going to do is 1,000 divided by 3.7725. So 1,000 divided by 3.7725. And what we should get here is 265. Now you have to round down, no matter what number you get. If it's 265.9, you still have to round down, because you either have a full crayon or you don't. So the answer to this one is 265 crayons. Okay. Basically, a stadium is designed in the shape of a cylinder. The cylinder has a height of 35 meters. The radius of the stadium is 100 meters. Okay. Radius of the stadium is 100 meters. A light rail is constructed in a tunnel which passes directly through the centre. So you can see that there's half a cylinder of a tunnel being cut straight through the stadium. Okay. So the first thing it asks is find the volume of the stadium including the rail line in terms of pi. So basically it wants me to find the volume of a cylinder. Okay, so I'm just going to put this for part 1. Volume of the cylinder is pi r squared h, and it wants it in terms of pi, so it's going to be pi times 100 squared multiplied by the height of it, which is 35. Put that in the calculator and it's going to be 350,000 pi, so it's actually quite a huge stadium. Okay, so 350,000 pi. Okay, so that's part 1 in the top right. Okay, part 1 is there. Now remember your meters cubed for full marks. Okay, meters cubed. Part 2, find in terms of find the volume of the rail tunnel. Now the rail tunnel is half the volume of a cylinder. The volume of a cylinder is pi r squared h. Volume of that tunnel is going to be a half pi r squared h. So all I got to do is multiply a half by pi, radius being 100 squared and the height being 35. Just put that direct into the calculator. Oh, sorry, excuse me, I got the height wrong. The height is wrong and the radius is wrong, excuse me, it's too big. The height is actually 200 meters, excuse me, because the height is the length of the cylinder. And the radius I'm just going to look for now. Radius is 5. It would have been way too big a number, so it's a half pi times 5 squared by 200. Because remember, the length of the tunnel is 200 meters. That makes the height 200 meters, and it tells you that the radius is 5. So this time it's going to be 0.5 multiplied by 5 squared multiplied by 200. 2,500 pi centimeters cubed. Now finally, express the volume of the rail tunnel as a percentage of the volume of the stadium in the form A over B percent. So look, the volume of the tunnel is 2,500 pi. The volume of the entire stadium is 350,000 pi. We're going to multiply this by 100 over 1 to change it into percentages, and whatever that comes out to be in the calculator. 5 over 7, which is 70.
That's right.
Sorry, just give me a little look at that. 2,500 divided by 350,000. 1 over 140, which is oh yeah, and then multiply by 100. It's 0.7%. Yeah. So this 0.71, okay, but what it does is it wants it in 0.71%. It actually doesn't want it in decimal mode. It says here it wants it 5 over 7%. Okay.